Okay, part C of question 16. I've started off and just written down the equation and then drawn the path of the projectile on a little graph. And the important thing to notice here is that if we draw a tangent at any point on the graph, that would give the direction of motion of the particle at that point in time. And of course we know that the gradient of the tangent is dy by dx. So if we differentiate the function, we end up with dy by dx equals c minus 9.8x over u squared. Let's substitute in the value for u, which leads us to this result, and simplifying gives us that dy by dx is equal to c minus x over 5. So this will give us the direction of motion for any value of x. Now we are interested in the point where the direction of motion is perpendicular to the initial direction of motion. So what we're going to do first is find out what that initial direction of motion is. And to do so, it is as simple as substituting x equals to 0 into this derivative, and we get dy by dx equals c. So the initial direction of motion is equal to c. Okay, so the perpendicular direction of motion will simply be the negative reciprocal, and so in other words we are interested in when dy by dx equals minus 1 over c. So if we now solve, c minus x over 5 is equal to minus 1 over c, then in just a couple of steps we are able to achieve the correct answer for this problem. And that's it. There is another way of solving the problem, which essentially would involve you working on horizontal and vertical motion. It's a little bit more long-winded. However, if you're not happy with this solution, then let me know and I will solve it the other way.